Exercise 7.10, question number 6. Integration 0 to 2 dx upon x plus 4 minus x square. Now we try to make denominator as perfect square dx. So we write 4 minus x square minus x. 0 to 2 dx divided by 4 minus x square minus x. So 1 by 2 square minus 1 by 2 square. So it will become integration 0 to 2 dx divided by 4 minus. These three terms will become x minus half whole square, and this will become, because of this minus sign, this will become plus 1 by 4. So we write it further, integration 0 to 2 dx divided by 4 plus 1 by 4. This will become 17 by 4 minus x minus half whole square. Now let's assume x minus half equal to t, dx equal to dt, and then we change the limits when x equal to 0, t will be minus half. When x equal to 2, then t will be 3 by 2. So our question becomes integration minus half to 3 by 2 dt upon, this will become root 17 upon 2 whole square minus t square. Now we apply the formula integration dx upon a square minus x square equal to 1 upon 2a log modulus a plus x divided by a minus x. So it will become 1 upon 2a, here a is root 17 by 2. So 1 upon twice of root 17 by 2. So 2 will cancel out. And then log of a plus x. Here a is root 17 by 2 plus x. X is t divided by root 17 by 2 minus t, and limits minus half to 3 by 2. Now further we put values of t. So 1 upon root 17 times log of root 17 upon 2 plus 3 by 2 divided by root 17 upon 2 minus 3 by 2 minus log root 17 upon 2 minus 1 by 2 divided by root 17 upon 2 plus 1 by 2. Now we simplify. So it will become 1 upon root 17 log. Let's simplify it. It will become root 17 plus 3 divided by root 17 minus 3 minus log root 17 minus 1 upon root 17 plus 1. Now applying property of log m minus log m, it will become 1 upon root 17, and this will become log of root 17 plus 3 divided by root 17 minus 3 multiplied by root 17 plus 1 upon root 17 minus 1. So it will become 1 upon root 17 log of 20 plus 4 root 17 divided by 20 minus 4 root 17. And if we take out 4 from here, so it will become 1 upon root 17 log 4 is common, then it will become 5 plus root 17 divided by 4 is common in denominator also, 5 minus root 17. So 4 will cancel out. Now, if we wish, we can rationalize this term, and on rationalization, we will get. I'm not writing the steps. That is your work. So it will be 1 upon root 17 log of 21 plus 5 root 17 divided by 4. Now, let's go to next question. Question number 7. Integration minus 1 to 1 dx upon x square plus 2x plus 5. Here again, denominator is to be converted into perfect square. So dx upon x square plus 2x plus 1 minus 1 plus 5. So that is equal to integration dx divided by x plus 1 whole square plus 4. Integration dx divided by x plus 1 whole square plus 2 square. Let here limits are minus 1 to 1. Let x plus 1 equal to t, dx equal to dt. Let's change the limits. When x equal to minus 1, t will be 0. When x equal to 1, t will be 2. So our question will become 0 to 2 dt upon t square plus 2 square. If you remember the formula, integration dx upon x square plus a square, it becomes 1 upon a tan inverse x upon a. So here a is 2, 1 upon 2 tan inverse t upon 2, limits 0 to 2. On putting 0, it will be 0, but on putting 2, it will be tan inverse. So it will become 1 by 2 tan inverse 2 upon 2, which is tan inverse 1, and tan inverse 1 is pi by 4. So 1 by 2 into pi by 4 will give pi by 8. Now let's go to question number 8. Question number 8 says integration 1 to 2, 1 upon x minus 1 upon 2x square e power x, sorry, e power 2x dx. Here we can separate it like 1 to 2, 1 upon x times e power 2x dx minus 1 to 2 integration 1 upon 2x square times e power 2x dx. Let's integrate first part, keeping second part intact. So it will become, this is first, this is second, integration by part. So 1 upon x times integration of e power 2x will give e power 2x divided by 2, limits 1 to 2, minus integration d upon dx of 1 upon x, that would be minus 1 upon x square times integration of e power 2x will give e power 2x upon 2 dx minus this term, same limit, 1 to 2, and here this is 1 to 2 e power 2x dx divided by 2x square. Here, because of this minus sign, this will become plus. So these two terms will cancel out. So 1 upon x e power 2x upon 2 limits 1 to 2 plus integration 1 to 2 e power 2x divided by twice of x square minus limit 1 to 2 e power 2x dx divided by twice of x square. These two terms will cancel out and we will be left with this term. So here limit is 1 to 2. Let's put the limits. So when we put 2 here, so what do we get? On putting 2, we will get 1 upon 2 e power 4 divided by 2 minus, on putting 1 we will get 1 upon 1 e power 2 into 1 divided by 2. So it will become e power 4 divided by 4 minus e power 2 divided by 2. So e power 2 by 2 can be taken common. So we will get e square by 2 minus 1, which is our answer. Now, let's go to question number 9. Question number 9 says integration 1 by 3 to 1 x minus x power 3 whole power 1 by 3 divided by x power 4. Here, we will try to take out x cube common. So 1 upon 3 to 1. To take common x cube, we have to write it as x, if we write it x power 4 upon x cube. No, rather it can be written as, we want to make it x cube. So we divide it by x square. So this term will become x, and minus second term is x cube whole power 1 by 3 dx divided by x power 4. So here, if we take x cube outside, then it will come out with power 1 by 3. So 1 by 3 to 1, x cube common with power 1 by 3 Then inside the bracket, it will be 1 upon x square minus 1 whole power 1 by 3 dx divided by x power 4. Here, 3 will cancel out. So we will have 1 by 3 to 1 x 1 upon x square minus 1 power 1 by 3 divided by x power 4 dx, where 1x will cancel out and in denominator x cube will be left. So our question will be 1 by 3 to 1 upon x square minus 1 power 1 by 3 dx divided by x cube. Now let 1 upon x square minus 1 equal to t. Then minus 2 upon x cube dx equal to dt. We have dx upon x cube. So dx upon x cube equal to minus dt upon 2. Now, so our question will become integration. This will become t power 1 by 3 and minus half dt. Let's change the limits. So when x equal to 1 by 3, when x equal to 1 by 3, then what about t? So 1 upon 1 by 3 means 1 by 3 squared, that will give 9 minus 1 equal to t. So 9 minus 1, that is 8. So lower limit will be 8. And when x equal to 1, so when we write x equal to 1, so 1 upon 1 is 1 minus 1 equal to t, then t will be 0. Now minus 1 by 2, this will become t power 4 by 3 divided by 4 by 3, limits 8 to 0. So it will become minus 1 by 2 multiplied by 3 by 4 times t power 4 by 3, limits 8 to 0. When we put 0, we will get 0. But when we put 8, then it will become minus 1 by 2 into 3 by 4 times 0 minus 8 can be written as 2 power 3 whole power 4 by 3. So 3 will cancel out. 2 power 4 will be left. And 2 power 4 means 16. And here there is minus sign. So this minus sign will become plus. So 3 by 8 multiplied by 16. So 8 to the 16. So answer will be 6. Let's go to next question. Question number 10. If fx equal to integration 0 to x t sine t dt, then we have to find out f dash x. So here we can integrate it by parts. So fx equal to, using integration by part, we use Eilert rule. So we write t into minus cos t minus integration. Differentiation of t will give 1 and then minus cos t dt, and limits are here 0 to x, here also 0 to x. Now further, fx equal to minus t cos t, limits 0 to x, minus this minus minus will become plus integration 0 to x cos t dt. So fx equal to, if we put x here, so it will become minus x cos x, and then after putting 0 everything will become 0, plus here integration of cos t is sin t, limits 0 to x, so it will become sin x. So here there is slight confusion in steps, so I'm rewriting it, that will be better. So we are given fx equal to 0 to x t sin t dt. Then we use integration by part. So fx equal to t outside, then integration of sin t will give minus cos t minus integration of t, sorry, minus integration of differentiation of t. So differentiation of t will give 1 and integration of sin t will give minus cos t. Then dt. I'm not putting limits. Let's evaluate first and after that we will put the limit. Minus t cos t minus. Here this will become plus and integration of cos t will give sin t. And then limits are 0 to x. So after putting limit, what do we get? It becomes minus x cos x plus sin x, which is correct. Now we have to find out f dash x. So let's find out its derivative. F dash x equal to, here we can apply product rule. So minus first into derivative of second minus sin x plus second into derivative of first, that will be 1, plus derivative of sin x will give cos x. It will become x sin x minus cos x plus cos x. Here cos x will cancel out and we will be left with x sin x, which is our answer. Thank you for watching.